Okay, in honor of the new James Bond movie, we are starting Unit 2.3, which is bonding, so you too can know how to be a bond. Okay, the first step in bonding is determining valence electrons. So this is from the last unit, that's why this comes after it. So use this to quiz yourself and see if you can do this. If you cannot do this first step, then you need to make sure you understand how to do this, because this is, again, step one. So pause this video and try to find the valence electrons for carbon, nitrogen, and chlorine. Okay, so you should have gotten these answers. Carbon is in the 1, 2, 3, 4th column, so it has 4. Remember, we skipped the transition metals. Nitrogen is in 1, 2, 3, 4, 5, right here. And then chlorine is in 5, 6, 7, down here. Draw the dot electron structures for an element. So remember, for chlorine, it has 7, and that is how we write 7 valence electrons in dot structure form. So again, on each of these, I want you to pause the video, try it on your own, and make sure that you know how to do this, because again, this is step 1, and there's a lot more to go. Okay, rubidium, pause. Okay, you should have gotten 1. Magnesium, pause. And you should have gotten 2. Phosphorus, pause it. And you should have gotten 5. Krypton, pause it. Okay, you should have gotten 8. And aluminum, pause it. And you should have gotten 3. Okay, so remember, if you can't do this, I'd better see you after school, because you must be able to do this to move on. So, the first word we're going to look at is called chemical bond. And a bond is simply an electrostatic force, which means a positive and negative attracting each other. And it's between different atoms, and they bind the atoms together. Yes, that's a typo. Should be bind. Okay, so a positive and a negative attracting two different atoms, that's all a bond is. Okay, so there's several types of chemical bonds, and the ones that we are going to look at in this video are ionic bonding and covalent bonding. So an ionic bond results from the electrical attraction between cations and anions. And this type of bond forms between a metal and a nonmetal. Remember that metals form cations and nonmetals form anions. Cations are positive, anions are negative, and they attract each other and they make an ionic bond. Ionic bonds are formed by transferring electrons from one atom to the other. So literally the anion will steal the electrons from the cation. So here's an example. We have potassium and chlorine. Potassium is a metal, chlorine is a nonmetal. You can tell that potassium has 1 valence electron, chlorine has 7 valence electrons. And you will, as we see, an ionic bond happens when chlorine literally steals this electron from potassium. And as that electron travels to potassium, here's the dot structures, 1 dot, 7 dots. And as this electron travels to chlorine, you will make a positive ion, a cation, and a negative ion, an anion. And the positive and the negative, remember, attract. And so when they attract, they form an ionic bond right there. Okay, the second type of bond is called a covalent bond. A covalent bond is sharing 2 electrons. So remember, ionic means stealing, and covalent is sharing. This bond is going to form between two nonmetals. So for example, water is a covalent bond. Hydrogen and oxygen are nonmetals. And as you can see here, oxygen and hydrogen are sharing electrons, and hydrogen and oxygen over here are also sharing electrons. So here's the big idea in all of this. No matter what bond you're talking about, atoms are always trying to get to the stable electron configuration of a noble gas, which, if you remember, all noble gases have 8 valence electrons, with the exception of helium, which gets away with 2, but that's because he's special. So this is called the octet rule, that all atoms in the universe are trying to get to this magic number 8, hence the oct part of octet. And that's because it is more stable, it has lower energy, and electrons and atoms like lower energy because they're lazy. So consider the molecules of example of F2. Remember, that's 2 fluorine atoms. So here's what one fluorine atom's valence electrons look like, the dot structure. And here's another fluorine. You can tell that both of them have 7, and they're missing 1 each to get to 8. So what we're going to find out is that they are going to covalently bond, which means they will share these 2 electrons between each other. So that way, they both now have 8. So this one sort of has 8, and this one sort of now has 8. And they are sharing this pair, which is why it's covalent. So here's the electron configuration, and you can see that everything except this last pair is full, and so they kind of share those 2, and their orbitals will actually overlap. Okay, here's HCl. Hydrogen ion, chlorine ion, or not ion, sorry, hydrogen molecule, chlorine atom. Hydrogen has 1, chlorine has 7, and they will compensate by sharing. So now hydrogen has its full 2 because he's close to helium, and then now chlorine has its full 8. Okay, and then here's again the electron configuration. You can see chlorine and hydrogen are sharing that last orbital. Okay, so now we're going to talk about how to predict what kind of bond will be formed, and that's from electronegativity. And remember, electronegativity means how much an atom will attract an electron, which has a lot to do with bonding, because bonding is taking and sharing electrons. So you can see the connection there. So a kind of bond can be estimated by comparing the electronegativities of 2 atoms. And by comparing, we do this by subtracting their electronegativities. So if I know the electronegativities of 2 atoms and I subtract them, I can predict what kind of bond they will make together. So here is electronegativity difference, and here's bond type. So if you subtract 2 electronegativities and the difference is anywhere in the range of 1.7 to 4, it will be an ionic bond. If it's anything between 0.4 and 1.6, it's what we call polar covalent. And if it's anything from 0 to 0.3, it will be nonpolar covalent. Okay, so first of all, where do we get electronegativities? Okay, well, how we're going to get electronegativities is we have to look at a chart of electronegativities. You do not have to have them memorized. So this is where we're going to get them, is from a chart like this, where we have fluorine and oxygen. We can get the values off of there. Second, you're probably wondering, what on earth is polar covalent and nonpolar covalent? And that's what we're doing next. So, a polar covalent bond, remember, covalent means sharing, and so polar covalent is when they share unequally. So they're sharing, but one gets a little greedy. And the more electronegative atom is going to have one of the electrons the majority of the time. So hydrogen and chlorine, which is actually hydrochloric acid, the electron chills with the chlorine most of the time. And so that's unequal sharing, and you can tell that this side then kind of is positive and this side kind of is negative, which is going to make it polar because it will have two poles to it. But it's still covalent. Okay, nonpolar covalent is just a bond where everyone's happy, the electrons are shared completely equally, therefore there's not going to be any poles, no positives and negatives. It's just straight nonpolar, nothing's happening. Okay, so let's actually practice. Use electronegativity values to determine the type of bond that will form between the following atoms. So let's say you were given potassium bromide. First you would look up potassium and then bromine, and then you would subtract their two values and then look at your chart. So let's do that. So we go to here, potassium 0.82, bromine 2.96. Let's go back. Okay, 2.96 minus 0.82 is going to give me 2.14, which falls into the ionic category if you go back to that chart. Let's try another one. How about carbon and sulfur bonded together? Okay, again, we'll come here. Carbon is 2.55 and sulfur is 2.58. So let's subtract those two. 2.58 minus 2.55 gives us 0.03, which, looking at our chart, is nonpolar covalent bond. Let's do another example. This time I want you to try to do this on your own. You can just type in periodic table of electronegativities and you can find one. Okay, so you go to magnesium is 1.31, oxygen 3.44, and you get 3.44 minus 1.31 gives you a difference of 2.13, and that falls into the ionic category. Okay, last one. How about hydrogen and oxygen together? Okay, this is a hydroxide bond. So again, let's go look. Hydrogen is 2.20, oxygen is 3.44. So when we come back, we're going to take 3.44 minus 2.1, and we get 1.34, which falls in the polar covalent, which is going to make a lot of sense because hydroxide is going to be a base of water, and water is also polar. So there we go. Okay. So now something else that might benefit us is to arrange atoms from the most ionic to the least ionic. And this is going to be important, as we will later find out, because it will tell us where the electrons are and how polar a molecule is going to be. Okay, so you could do all the grunt work of going here, finding all the electronegativities, and then coming back here and subtracting them for each one of these pairs, and then I did it for you right here. 1.65, 2.06. So once you do that, then it's really easy to order them from most ionic to least ionic. Okay, so all you do is just find the number. The most is going to be potassium oxide with 2.62, and the least is going to be sulfur and oxygen with 0.86. So order those, least to greatest. Pause this video. When you're ready, press play. Okay, so you should have gotten from most ionic to least ionic potassium oxygen, lithium nitrogen, sodium sulfur, carbon fluorine, iron chlorine, and then sulfur oxygen. Sorry, that got cut off. Okay, so that is bonding, and we will talk more about this, do a lot of practice, and we will practice drawing bonding diagrams on Wednesday or Thursday. So I wrap up these notes, and I will see you then.